Well, good morning, everybody. I'm sure you're all expecting to hear Matt's voice this morning, but Matt and I swapped this week. I have to head out to California for a meeting, and so Matt and I are going to switch things up a little bit. He's going to take over the next 2 days. I also bet you did not expect to see a picture of a kid on a lawnmower, but many of you were asking, and I had several people that were curious about my son. He loves to mow, so this is my son Graham. He's 12 years old, almost 13. If you're curious what I look like at that age, it's this exactly. We share like nearly all of our DNA. But last week we built something for our mower, and some of you were asking about it. So we tried to build a cheap striping kit. The kid loves to mow. I think if I would just put him in front of a massive field of grass, he would just mow until he passed out. But this is what we built. See the big 4x4 on the bottom with the broom hint, or the brooms? That's what we decided to build behind his mower here so he could stripe lawns. And that's a neighbor's lawn. She's gone, and he wanted to make sure it looked good for her when she came back. And so he striped her lawn. And I was really impressed because as soon as she got home, she went outside and took a picture of it, which made me feel good. Anyway, that's my boy Graham. I've been telling him, you got to get this mowing done, kid, because the forecast is wet. If we just have a look at the next 7 days, we have a lot of moisture in the central part of the United States, a lot of moisture in the southeast, northeast. These are areas that have been wet for a while. We can see that parts of the Canadian prairie, getting into Montana, also here into the northern plains, are missing a lot of this precip, and so is the west. We're actually going to watch another pretty sizable heat wave move into the western United States again. These heat waves do not seem to be long in duration. They tend to last 2 to 3 days versus what they can do, which is for weeks. And in a few moments, we're going to talk about what that might look like should they get into that risk area of having prolonged heat. I think that's what the discussion is going to be. There is going to be a ridge somewhere across the United States. And every year it's a thought of, is it going to be here, or is it going to be there, or is it going to be here? And it's going to be in one of these three places. And we just need to find where that ridge axis is going to be in the middle of this summer. Now, for most of the last 30 years, it's been in the west. I mean, that's why these longer term trends for much of the central United States, especially Ohio Valley toward the northeast, have been wetter, right? We've seen this systematic shift where we're getting more of our heat in the middle of summer, greater amounts of it in the western United States, bigger ridges. I thought for a while, and I still do, at some degree, that we would be off of that trend this year, because that does happen. But I'm going to work on this case for you and kind of tell you what I think we need to think through here. All right, we do already have a large area starting on the Red River of the South, going through Oklahoma, Kansas, into Missouri. Flood watches to the north of that. We have our air quality issues here, and there's actually a frost advisory out here and a winter weather advisory as well. So we're just watching those two things too in the west, giving you an idea on how deep the wave is that's coming through. So speaking of this smoke issue, which we've been watching for several days, I wanted just to bring up last night's satellite data just as the sun was setting here to show you that smoke making it all the way down to the Gulf and off the East Coast here as well. We had great thunderstorm action in parts of southern Florida, one of our driest and hottest areas, and more deep storms that were just rolling through parts of the plains here coming into Nebraska. Nebraska's been front and center for me for a while, just given how dry it was at some points during the spring, But some of the moisture that's getting into this system here is from Alvin, and it's continued to make things quite wet. Now, Alvin's just a small component of it, but I wanted to show you that the remnants of a hurricane out of the East Pacific are contributing to the moisture. Not all of it, but some. Looking at the latest radar data, we can kind of see that this upper level this upper level low here and its surface component are going to be following the pressure trough set forth by this frontal boundary right in through this area, which means this is going to press to the east following this trajectory over the next 48 hours or so. Once again, this is a relatively deep system, and at some point, as we progress through the month of June, we're going to lose this. And what I mean is we're going to lose these more well-defined large low-pressure systems. That's a very typical seasonal transition. We just tend to get ourselves into very weak frontal boundaries. We tend to watch for outflow from decaying thunderstorms from the previous day and initiate new storms the next day. And we then get into all those discussions about northwest flow and mesoscale convective systems and who's going to get hot and dry and who's not. So we will make that natural transition here during the month of June. So that will be just something to keep you aware of. But as I watch this moisture move through the central United States, it reminds me again that this was an area that back in winter and spring were major concerns about how dry it was. And we addressed that yesterday. Yet over the next 10 days, this goes out all the way to Friday the 13th. This is just a look at the chance of getting another 2 inches of total moisture. If you want to see the 1 inch amount, it's much more expansive. That's the probability of grabbing another inch of total moisture out of the atmosphere. And here is 2 inches again. Yes, we'll talk about the tropical system that's just off the coast. And if you're curious, here's the probability of 4. So off the southeast coast, but here in parts of Oklahoma, we're getting very, very wet. Now we know that this area's been wet for a while. From the Arkansas, the White, the Red River here, through the mid and lower Mississippi Valley, into the Ohio Valley, the Tennessee Valley, this northern part of the southeast, and into the northeast. Exceptionally wet conditions so far from April. This is April, all of May, the first couple of days of June. We know that we've been a bit drier in this area, although moisture is coming through there now, and there's been just enough rain to kind of keep things going in this region without too much, I don't think too much stress overall in this region. Now the West has been much, much drier, especially in the Pacific Northwest, and we're getting hot yet again. But I want to just address something with this particular map, and I want to make kind of a point about one spot. If we just come back and we say, all right, where is it wettest? It's this kind of Kansas, Missouri, Arkansas, Oklahoma, northern Texas region. And there's a few rivers that run through here. There's the Arkansas River, the White River, and the Red River that are down here. And I wanted to use those rivers knowing that they've been so wet in their basins here. Now, I apologize. I'm just going to do it for here, not the Ohio Valley, not the southeast or northeast. We're going to look here today. But I wanted to look a bit at the history behind this and try to ask a question. So over the last 60 days, this area, on average, has about double its normal precipitation, while to the north of it, much drier over the last 60 days. And to the north and west of that area here, much drier. Now, these negative 10,000s, the AHPS data that is I used to make this map, whenever the data feed are not completed, coming from NOAA's resources, my code just puts it in as a negative 10,000 as a placeholder. So this isn't apocalyptic, it's just a data issue. Now, outside of that, let's just look around the rest of the country and kind of get our bearings set here on who's been wet and who's not. And I'm going to come back to this region right down here. So I went out using the Climate at a Glance tool from NOAA. It's one of my favorites. I went to the Arkansas, White, and Red River Basin, and I said, show me the 2-month precipitation ending in August, which looks like that, okay? And I wanted to compare it to what that same number looked like ending in May. So if you look at April and May, and so that's what the data look like. And the question is, because remember, I've made mention that occasionally we have a scenario where spring shows up extremely wet and summer shows up extremely dry, or one season to the next shows massive swings. And that has happened historically, but we'd like to know, is it a highly probable event? Does that make sense? Because I have a lot of folks that are quite anxious that after all of this flooding, that we're going to just flip the switch at some point in summer and get really dry. And I mentioned in a previous video, right, we talked about how spring of 23 bone dry in the Great Lakes states. And then we flipped the switch and it got really hot, stormy in the midsection of the country, July and August. And then we talked about 2024, which was extremely wet in the Western Corn Belt, upper Midwest for spring through June. And then by the time I got into August, September, October, it was record dry. So we have these recent memories of a flip-flopping pattern. So does the pattern flip-flop, right? And we're going to focus on the Arkansas, the Red and the White River Basin. So what you've got here on the y-axis is total precipitation for that whole basin, April to May, and on the x-axis, the July and August. So what you'd be looking for in this particular case would be data in this area. That's very wet for April and May, but very dry for July and August. And if you look at this overall, the first thing you need to understand is that using one season to forecast the next, when you look back to data going back to 1895, that's not a wise thing to do. In other words, one season's precipitation pattern does not lead to a conclusion about the next season or even the next month. But just to make a point here that while we have memory of patterns that flip, they tend to stand out in our memory simply because of their impact, but it's not common. Okay, that's the main point behind this. Now, thinking all of this through, I did want to tell you something, right? I went out and I found those really, really dry Julys and Augusts. And I want to tell you what needs to happen. We have these large subtropical highs that just hug North America. One's called the Pacific High, one's called the Bermuda High. I go on and on about these things. During those summers, July to August, and here they are listed, where the Arkansas, the Red and the White rivers get really, really dry. High pressure lives in Minnesota and Iowa. And it's there because the atmosphere's lost momentum. Deep troughs have dipped into the west and rolled up over a ridge, and the pattern is long enough that the waves don't progress east. They tend to stay put. The Pacific High, which is normally here, is moved. It's actually overtaken this whole region all the way to Japan. And the Bermuda High, which I'm labeling here, is clearly not near Bermuda. It's not even near the Azores. It's way up between Iceland and Ireland and Greenland. And that is the recipe that we tend to have for disaster if we're going to go over to super hot and dry in the central United States, specifically focus on that river basin. Now, what happens at sea level pressure? Well, this is really where those highs go, okay? So just have a close look at this. You've got right there your Pacific High. Your Bermuda High is way up here. You're going, wow, there's low. Yeah, but low pressure in summer is often associated with heat. Low pressure at the surface is often associated with heat, okay? And so that's what we're seeing here when we look out this far. All right, do we see it? In July, now this is going to update in 2 days. I'm excited to see it as always, but this is the current forecast for the month of July by the ECMWF for sea level pressure. And it's actually got a weaker than normal Pacific High here. Remember that during those super, super hot, dry summers, it has to get higher than normal pressure. And take a look over here. That would be where the Bermuda High is displaced. The current forecast is the Bermuda High is expected to be stronger here and weaker there. Now, is this model worth its weight in predicting pressure patterns months in advance? No, it's not. It's a clue, but it's not the end-all, be-all of how this is going to work. But right now, when we use our longer range forecasts to kind of predict that risk, it's not there. It's just not there yet. That doesn't mean it can't happen, but I'm just telling you that I don't have overwhelming evidence from a model that says that we're going to get there either in July or even into August. In fact, it's trying to drop the pressure in this area, taking more of the heat to the western United States. All right, that's just a quick assessment of what's going on here with that particular basin. Now, I go on and on about ocean temperatures, right? And there's a reason for that. In July and August, if you're going to see major heat and drought episode here and not here or here, it's got to get cold there and cold there. All of the historical precedents, like these years, when put into composite, have a lot of warm water here and warm water there, and they have a pattern that looks something like this by the time we get into July and August. And we are not quite there yet. That's our current global average ocean temperature compared to today's global mean. So I'm looking at this to find relative differences. Hey, we got some warm water here and there. There's some cool water there, but it's not here. And this is warm when historically that would need to be cold, colder than average. So we have pieces of a risk package here for a flipping pattern, but we don't have all of the pieces. So there's just not overwhelming supportive evidence that I should be telling you in the Mid-South, get ready. I don't have it yet, okay? Now, if we continue down this line of thought, I also want to make this point. When you stitch all of those years together, those are the ones that we got really hot and dry in July and August in the Arkansas Red and White River Basin. They were already very dry here in April and May. And you've already seen that is not what we have so far. So there's more evidence against it than for it, but it doesn't mean that the probability is zero. So what we need to do, what do we take away from this? Watch the ocean temperatures, and then let's go back to it here real quick. There's the ocean temperatures, there we go. We need to watch, if for other reasons I haven't identified, if the Pacific High starts to strengthen there, and the Bermuda High moves. Now, if this Pacific High strengthens over the west and the Bermuda High slides back down here to Bermuda, we put kind of the squeeze on North America. We tend to get drought in the corners, the northwest and the southeast, and it storms like mad in the midsection of the country during summer. So that's the other side of this equation we can't forget, okay? All right, with all that being said, let's go out and look at a couple of other things. How about this? May of all those years where it was really, really dry here. What was going on? We'd already lost right there. We'd already lost the Bermuda High by May. It was gone. Low pressure had already started to move up toward the North Atlantic. We had really strong flow that came through here, and then it was able to do nothing in this area to revive moisture. This is where we are, right? We talked about this several times. Our jet stream went north, giving us this really significant risk. This is what created all those wildfires in Canada. But we had a component of the Bermuda High. And so as a result, flow was going around this, and those weak lows tapped into it, and that's why we saw such tremendous flooding. And that Bermuda High is still hanging out. Just take a look at it. It's all of this. There's a part of it. There's another extension of it. There's another part. It is what is keeping the Gulf open. And here's the frontal boundary on which we're going to watch all that rain flow. And as I play forward, by the way, there's the Pacific High hugging the northwest coast. That's why it's going to get hotter and hotter there. As I just play this forward, I mean, what I notice here is, we have a little weak tropical system to be talking about taking shape off of the coast of the Carolinas, but we cannot argue that our flow is not, doing anything but just ripping through the Caribbean Gulf and pouring into the southern part of the United States. That's out there on the 7th. We can just keep going 8th, 9th. There's a little weak non-tropical low moving off of the coast, but look at this moisture. And it's just coming. In fact, if I flip this over and just show you total precipitable water, you can see it's loaded. Got plenty of it in there. And that Bermuda High has yet to just drift off and leave this area vacant, which is why we're going to be looking at several days of wetter conditions. Now, I keep mentioning this non-tropical low here. National Hurricane Center is giving it a 10% of developing, but again, calling it a non-tropical area of low pressure, so we're not looking at a hurricane developing here, but we need to keep an eye on it. But I'm going to come back to one other thing. The GFS is still trying to produce a phantom tropical system in its longer range outlook. Now, we're going to come back to another model run in a minute, but I want to show you this. I'm just playing it forward. There's the little weak tropical system by the end of the week. Non-tropical system, sorry. But watch what it's doing way out here. This is Sunday the 8th, Monday the 9th, Tuesday the 10th. There it is. From the Caribbean into the Bay of Campeche and then into Mexico. Remember, over the weekend, we saw this coming into Louisiana, Texas. One time it was going to hit Florida. We had one that came over here, was expected at Florida at Cat 5. I'm just letting you know this is a GFS kind of issue, right? Now, we do know that the lid, I talked about this yesterday, is getting taken off of this area through this major convectively coupled Kelvin wave that's just moving better upward motion into this part of Central America or the Caribbean or the Gulf. But I don't think it's going to spin up a tropical system. I think it's just an artifact of the modeling there. So let's just be clear on that. So where are we? We've got our 3 maps across the top here that show severe weather risk today. That's on the left, tomorrow in the middle, and on the right we have on Thursday. But you can see right below it the CPC's excessive rainfall outlook. We're going to be watching this area multiple times over the next 4 to 5 days for extremely heavy rainfall. Now, I've been mentioning that all of this excessive moisture that starts in the northeast moves down through the mid-Atlantic into the southeast and then through the Ohio Valley, which has caused major problems in the eastern Corn Belt with getting a crop established and planted between the cool weather and the rainy weather. It's been very difficult. And then you come down here to that basin we've been talking about, the red, the white in the Arkansas River. And I want to show you something. As I play this forward, you're again looking at precipitable water. Do you notice that our highest precipitable water amounts by Wednesday are here? And they're not directly connected to the Gulf, meaning that the local environment is supplying additional moisture into this area. And you can see it. I can just keep playing. Let's go out to, Friday. There it is again. See that? So this is the additional water being shoved into the atmosphere through evaporative processes that is supplying these rainfall events with just intense rain. So let's go look at it. Let's just add up all the precipitation first. Let's go to total precip. This was the rain that just fell last night. As we play it forward, this is spreading through Iowa, Wisconsin, Illinois, Missouri, already by Wednesday, the possibility of over an inch here easily. Down in Oklahoma, but watch, there's the weak non-tropical low that's going to form off the coast of the Carolinas, keeping it wet here in the coastal Carolinas after going through Florida. And then as we play it forward, that's through Sunday into Monday, Tuesday, Wednesday of next week. And if I take you out 10 days, that's a whole lot of rain getting put down by the European model. Now, as you look at the type and intensity, this is how it kind of shapes up. Let's start this off on Tuesday. Again, we're going to keep an eye on the strong storms. There's just a frontal boundary here between two areas of high pressure. There's one over there, there's one over here, and that's just where the atmosphere is getting squeezed. We have frontogenesis, okay? Now, playing this forward, that's Wednesday into Thursday. There's the non-tropical low just hovering by later this week off of the coast of the Carolinas. And then we just see the frontal boundary stalling here. That's Saturday into Sunday. Stronger low goes through parts of Ontario at this point. We need the rain in this area badly, but there will be strong winds around that. And then we take this out into Monday and Tuesday of next week, where things kind of clear out behind this low for the midsection of the country. We can see a frontal boundary again going over where we have those fires, and the previous front just lingering right down here. So that's out to Tuesday, June 10th. And then as we get out there to the 11th and 12th, it's still there is moisture in this particular model. So with all that being said, let's go ahead and have a look at where we end up after that. One interesting thing keeps showing up in the longer range models. So this is about to June 9th. After I get out there to the 11th, 12th, and 13th, the ensemble averages are trying to open a pretty sizable ridge here. Okay, you can see it, the height lines with the trough off the coast. And as I play it forward, it kind of sticks around through the middle of the month. Now, we were expecting a pattern change past the middle of the month. But is it due to the Pacific high going here and a trough hanging off the west coast and more permanent high pressure here? I don't know. I'll be honest with you, this is going to be a test. We know we watched this big MJO movement. I'll show it to you in a few minutes. Are we done with those? If we are, then seeing the pattern get stuck like this could be something that would be a more frequent thing to watch. But I'm very skeptical of it, mainly because of the analysis I did for you at the beginning. So what do we see out of that? Well, the week 2 precipitation forecasts all look like this, and the CPC is the wettest, if you kind of just look at their overall map. It is interesting to note that the European, the AI model, and the GFS, okay, they all have a similar, see it right in there, drier region. And I want to keep an eye on that area, and I'll tell you why in just a few moments, okay? Temperature-wise, though, let's take a look at today's highs. That's tomorrow, Wednesday. Much cooler in the central U.S. while we're getting hot in the northeast. Watch the heat come back on in a big way in the west here. Ready? This is Friday, Saturday. Now we're back up in the hundreds in the Central Valley, deep into the 90s as we go farther into the northwest. That's Sunday into Monday. So we're looking at near normal to cooler than normal temperatures in this area. So when does it warm up there? Well, there's your next 5 days. This is a sliding window to take us out today 5 through 10. That's when the heat really pours on in the west. And then we go out there, well, cool down here compared to average, mainly due to cloud cover and precip. You saw that stalled out boundary. And then we go out there to the end of the time period, and hey, we're starting to see something that brings a more consistent heat into this area and throughout the Great Basin, the Rocky Mountains, the Intermountain West. And that could be this pattern we land on late in the time period. That's, again, after the middle of the month. Now, there's some support for this, but it's not necessarily in ocean temperatures just yet. Take a look at what's happened over the last week. We've had a very strong and persistent wind here causing upwelling in this area. We've seen upwelling taking shape here and here, giving us some colder water, while all around it, it's been getting warmer, including the Gulf of Alaska. This has gotten considerably warmer as well, right in through there. Now, those are the kind of week in and week out things we keep a close eye on, but it's not the end-all be-all of how this pattern's shaping up. Right now, there's pretty strong evidence that this big jump out of the MJO is what's going to really give us some issues to think about. Now, if I come back to this and say, well, it's interesting to see all this cool water here, you could honestly make a case that over the next couple of weeks, we're still in a very Niña-like environment. And what I mean by that is, these blues, these cool colors, represent stronger trade winds. And that's the Pacific. There's the international date line. I got some interesting behavior in it going forward. That's kind of fun. But that's the forecast. But you could still make an argument that there are surges of easterly winds giving rise to the, well, let me rephrase that, preventing the death and demise of just a full La Nina state of the atmosphere. But these little intrusions of westerly wind bursts, like right there and right there, are what's key to watching this because they're influencing where the deepest convection is. Now, Matt and I love to show you these, and I understand some of you might look at this and go, I could turn that into a t-shirt. That's kind of a pretty cool time. No. We just look right here. Now, these are anomalies, differences from normal. So the best rising motion in the world in the equator is right there. But for the last, going back to March, we just keep every couple of weeks, we have these little events. There was a big one there. That's what set off all that severe weather. We just finished one. And we're curious, are we going to do that? See them? Those are MJO movements. All right. Now, if we look at the forecast, here's the one that's just starting. And that gets us to the middle of the month. What I want to know is this. Does the best rising motion keep going back in this direction with time, limiting these? Because if that occurs, the second half of this month will look entirely different than what I just spent all this time talking to you about over the next 2 weeks. Now, do we have any evidence for that? Well, we could go look at the Climate Prediction Center's site. This is their, I should have showed you this yesterday, but this is their June 14 to June 27. That's most of the second half of the month. They're bringing in quite a bit of heat in this area, keeping it very wet in the southeast. But they did just add this in, and they've got very dry compared to average in the Great Basin, up to parts of Idaho, Montana, eastern Oregon, and Washington. Another thing just to make note of here is they did update on the 31st their drought outlook. And they continue to call the riskiest areas for drought development, Montana, whole spring wheat belt up here, Red River Valley, Western Corn Belt. They are expecting this area to continue to have the risk of June 1 to August 31 drought development. They have it in the development category. And I think I understand why they're doing this, but I want to make a point for this. That is most, if you just think about it, it's most of the Missouri River. There's the Missouri. Okay, it just maybe doesn't include that part of it, but that's the Missouri River Valley. It's a huge river. Okay, so I decided to do the same thing I did at the beginning. Show me the Missouri River Basin in July and August, and I want to look at all their wettest and driest years and specifically focus in on the driest. Now, the driest years are all listed right up here. Now, this is the Missouri Basin, okay? What happened in April to May? Well, we were extremely wet down here and dry there. And we've not had that this April or May, right? There's more than one way to skin a cat, as my grandma used to say. And what I'm trying to say here about this is that if the Missouri Basin is going to get very hot and dry, we at least know what needs to happen. It's the same narrative. Bermuda High gone. In its wake, high pressure that sits over Minnesota. Deep troughs of lower pressure, cooler weather to the west. And as that typically happens, the near surface pressure patterns build a ridge there and a ridge there, and in the middle, in the void, you get this. So you're saying, Eric, put this all, here's what this means. If the Pacific high over the next 40 days goes here, the west is going to absolutely bake. And there will be just all sorts of ridge-riding thunderstorms in the midsection of the country, feeding on all the water that's currently coming from the Gulf and in the really wet soils here. If the Pacific high starts to move north and west of Hawaii and the Bermuda high shifts here, we'll shut it all off. The west will be cool. The southeast will be extremely wet. And that's what I'm waiting to see if it's going to happen. Which of these two modes is the atmosphere going to go into? And we'll just keep thinking about it. And Matt's going to work hard on it for you the next couple of days. And we'll just keep talking about it. I appreciate your attention. I'll talk to you on Friday. Matt will take over the next 2 days. Thanks.